Hello everyone, welcome to day 16 of Leetcode May Challenge. Today we have question number 1091, shortest path in binary tree. In this question, they have given us n cross n binary matrix and we have to return the length of the shortest clear path in the matrix. If there is no clear path, we have to return -1. A clear path in a binary matrix is a path from the top left cell to the bottom right cell such that all the visited cells of the path are 0 and all the adjacent cells of the path are adirectionally connected. That is, they are different and they share an edge or a corner. The length of a clear path is the number of visited cells to this path. In example 1, they have given us 2 cross 2 grid and we have to find the way. If the cell we are on the top left corner and we have to reach the bottom right corner, and we can only move in the cell if it had its value 0. So we have to, in order to reach this, we have the direct path and the length is 2. That is what we have to return as an output, and we can clearly understand this question from this example. Let me change its color. In this question, we have to make sure that we are on this cell and we can only move if it is 0. So our first thing is, if this cell, if the top left corner is 1, then we cannot move further and we cannot reach to the bottom right corner. So that's why in this case we will return -1. Similarly, if in this case top right is 0, then we will create we will start finding the length to reach the bottom right of the grid. But if the bottom right is 1, then of course our answer will again return -1. So in both these cases our right answers will be -1. So first, this is the base case or the corner cases. While starting the algorithm, we have to check if the top left corner is 1 or the bottom right corner is 1. We just have to simply return -1. That is, in no way we can reach down, or if this is 1, there is no way we can reach. If we reach till here also, then again if it is 1, we can't reach over here. Let's understand it from this example, like how we will move from top left to the bottom right. So first thing is, the basic approach we will use is BFS traversal. We will maintain an array which will have its x and y index, x and y axis. It has its x and y coordinates and with the value present in it. So first we will create a queue, and in the queue first we will add its axis, that is, it's on x it's 0, on y it's 0, and its value is 0. And as we are pushing this in the queue, we will make sure that after pushing it, we will make this as, we will give this value as 1, so that if there is no self loop, like for example from this one it can move to 8 direction, that is here, 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 in this cell, diagonally upward, downward, left diagonally up and down. In these 8 direction it can move, and it can only move if the cell has the value 0 in it. So if we just give 0 and it will move in all the direction, when it will come to this, it will again go to this cell, and they will just have the self loop in them. So to avoid that condition, when we are pushing this in the queue, we will mark this as 1. So now this cell has become 1, and what we will do is, and their count is 1, like we are on the length 1. So this is the count, so their count is 1. And now we will pop them, and then we will add the 8 direction it can move to, but we can only add those cell who has the value 0. So out of this, it can go in this direction or in this direction or in this direction, but as both of this have 1, so it can only move to its right. Then we will push this, that is 0, 1, when it will go into this, its length will become 2, so that is the length. We will push this, and then we are done, and then we will move this out of the queue and make it 1, so that there will be no condition of self looping. And again from this we have 3 ways, like we can choose to go here or here or here, but as this is 1 we cannot choose it, so we will push other 2 ways in the queue. So first one is 0, 2 and its length will become 3 if this thought to move with this direction. But what if it thought to move with this direction? Then in the same fashion it can also move from 1, 2 and its length will also be 3. And then we will move this out and make it 1, and it has an option to move only in this direction or in this direction, but as it is 1 it can move only downward. So what we will do is we will add its level, that is 1, 2, and with the value it has the length till here, the length is 3, and if it is moving downward its length will increase by 1, so with the value 4. And then this is done. Then we will pop out this, and this is, we are already over here, so we will mark this as 1 and we will add this. So this is our AND index, that is 2, 2 and its length is 4, that we have pushed in it. And afterward if we'll reach here we will just return the length, and we reached over here. And now this, when we will pop out this from the queue, we already know that it has the value 1, so nothing to do, continue, and if we are reaching there we'll just return the answer 4. So what we understood is there are 2 ways of reaching this bottom right corner, that is using this direction, or but if we are using this direction its length would be 1, 2, 3, 4, 5, its length would be 5. But if we are using this direction from this and then this, its length would be 4. So obviously we have performed the queue operation, and over here it's performing this way, like when we are on the length 4 it will reach faster to the bottom right than the 5th one, so that's why it's taking the minimum length, and that is how we are returning it. Let's move to the coding part. First thing what we will do is we will find its length, grid dot length integer n is equals to grid of 0 dot length, and then first thing is we will check if grid of 0 have the value 1 or grid of m-1 and n-1 have the value 1. Simply we have to return -1, that is we can't find the clear path. Okay, neitherwise what we will do, we will create a queue of integer array, name it as q, and q we will put where it is on x-axis, where it is on y-axis, and what its cost. And then we will make this particular 0, 0 as ones to avoid the self loop, and the basic BFS function we will form if q is not empty. Then first thing is we will find its size, and while size minus minus is greater than 0, q dot, we'll poll this from the queue. And what we will make sure, we will, after this we will create an array which will cover all the 8 direction. Then we will poll from the queue the first, the 0, 0 that we have pushed over here, that is this. Then we will poll it, And what we will do, we will check if this is equals to m minus 1, if they have reached to the bottom right, we will just return the length. If it's not, then what we will do, then we will loop in all the direction. And we will find the row point of 0 plus direction of 0 and column point of 1 plus direction of 1. And if we will check, like all these points are lying between the boundary, it's not out of bound, so that is what we are checking over here, putting the condition that that's no point is going out of the grid. And the most important thing, the grid should have the value 0, then only we are going to push this in a queue. Add new integer array, which will, like, we will give the row, the column and the point which it already have plus 1 because its length is increasing. And then simply once we are done with this, that grid value will change to 1, no self looping. And then we will return, if this spells all cool, it's good, we will get the point over here. If not, it will return -1. Let's run it. Okay, I have done this wrong, this should not be this. Yeah, now it will work. Let's submit it. We are done.